Hi everyone. Hi everyone. Welcome to the class, guys. How are you? Am I audible and visible to everyone? Tamelong, Shillong. Okay, very good. Tamelong. Shillong, are you there? Okay. Can you please tell me what topic are we discussing in the previous class, so that we can proceed after that? I guess so. We have started with the metals and the non-metals, and we have discussed some portion of that. Okay. So guys, let's start with the recall test first of all. Okay. Again, 5 questions. Just mark answers in your notebook, and then just inform me once. After that, we will check out the solutions. Please do these questions. Please do these questions and confirm me once. Anyone there at the Shillong Center? And Tamalong, please mark your attendance. Okay. All the metals except dash exist in solid at room temperature. Yes, this is absolutely correct question. Done, Tamilong. Attempt this one as well. Okay, so let's check out the answers. Check out and tell me how many correct you have got, and if you have any doubt, please ask me. Okay, congratulations, very good. Okay, now let's start with today's session. There is a question that what happened when metals react with the O2. Okay, so in the picture you can see there are a few metals, okay, which are shown over there, and we are treating them with the oxygen. Okay, so first of all, understand one thing, that whenever a metal is being treated with the oxygen, it will form metal oxides. Okay, metal oxides can be of many types. We will discuss about that later on. But first of all, you have to learn one thing. Whenever a metal is being treated with oxygen, we'll get the metal oxide. See, the general reaction is also written over there, that metal with O2 will give you what? Metal oxide. This is the, we can say, the core line of this concept. Okay, so please copy this line. Okay, that metal on treatment with the oxygen will give you what? Metal oxide. Okay, and then we will proceed. Make the heading, copy that, and after that just tell me you have copied that. Hi, good evening, Itanagar. Nice to see you. How are you? Okay. Now, reaction of metals with the oxygen. There are certain elements given to us, like aluminium on treatment with oxygen will give you what? Al2O3. Sodium gives you the oxide of Na2O. Okay. Magnesium, first of all, guys, listen to me. Listen to me. After that, you will copy that. Magnesium does not react with oxygen at room temperature, but on heating, magnesium metal burns in air, giving intense heat and white light to form magnesium oxide. Okay. So ultimately, this is the reaction of magnesium with the oxygen, which gives you what? MgO. Okay. So what you have to do, you have to remember these reactions. When aluminium is being treated with oxygen, it will provide you the Al2O3. Sodium will give you what? Na2O. Whereas magnesium will give you what? MgO. Okay. Please copy this one, and after copying that, just inform me once. Copy and then confirm. Copy and then confirm. copied. Itanagar, have you copied that? Okay, so let's move on. Types of oxides. See, oxides are of four types: acidic, basic, amphoteric, and the neutral. Okay. So now the question is how we will identify the acidic oxides, basic oxides, amphoteric oxides, and the neutral oxide. Okay. So we will move on to the discussion part. But before that, just make the heading types of oxides and draw this flow chart over there. And after that, we will discuss one by one what acidic, basic, and amphoteric oxides as well as neutral oxides. Copy and then confirm. Okay. Acidic oxides. Okay, so first of all, you need to know that acidic oxides are formed when oxygen is being combined with the non-metals. Non-metals are generally present in the periodic table on the right hand side, which is the p block elements. Now the question is how we can identify the particular given oxide is acidic in nature. So for that, just pick up that oxide, dissolve it into the water, and after dissolution, if we get acid, then it would be the acidic oxide. If on dissolving into the water, the oxide get converted into a base, then you will say it is a basic oxide. And if an oxide can be treated with acid as well as a base, you will say it is a amphoteric oxide. Amphoteric stands for what? Having both type of nature, acidic nature as well as the base nature. Okay. Whereas the fourth type is what? Neutral oxide. Neutral means oxide which won't react with anyone, acid or a base. We'll say what? Neutral oxides. Okay. So this is how acidic, basic, amphoteric, and the neutral oxides are different from each other. Okay. So the first one is what? Acidic oxides. So please copy this one. I hope so it is clear to everyone. Just remember one thing that if you would like to know about the nature of the oxide, just dissolve that oxide into the water, and then if it makes acid, you will say it was the acidic oxide. If it makes a base, then you will say it was the basic oxide. If reacts with acid as well as base, you will say it was the amphoteric oxide. And if it don't react with anything, you will say it is neutral. Okay. So I hope so it is clear to everyone. Now please copy this one. Okay. Please copy and then confirm. And yes, if you are still having some doubt, you can please ask me. Copy and then confirm. When we dissolve amphoteric oxide to no water, what will it give? It won't give anything, na? Amphoteric oxide. You are still saying it is amphoteric. Water is itself amphoteric. Okay? So we won't get acid or a base. To check out the amphoteric nature, you need to treat that amphoteric oxide with acid or base, just to prove that. Okay? It is like that we are mixing up the amphoteric with the amphoteric. No sense. How can we, how can its acid or base without using indicator? Without using indicator, see, first of all, make sure that you will dissolve it into the water and then it will convert it into the acid. Then that acid will change the pH, or we can say the, not pH, that indicator. Okay? Before that, you won't do this. For the neutral oxide, same. About which you are talking, Itanagar? I guess you are given 3-4 questions back to back. Okay, so please just confirm me once after for the last question. But before that, just write your question. Copy this all 4 types of oxides. Okay, I'll answer this question. Please write your question again. Means I'm not getting clearly. Then that means no chemical reaction will occur. Means this is for which? Please copy and then confirm, guys. Copied. Please copy this one as well. Basic oxide reacts with water to form the alkaline solution and turns red litmus to the blue. Means that solution will turn. Oh, wow. Please copy and then confirm. Neutral oxide won't dissolve in water and it will remain in the same state before. Yes, neutral oxide won't react with the water. It will remain as it is. Neutral means unreactive. So it will remain same. I guess we have discussed about the indicators earlier, now in detail. Please copy and then confirm. See, to check out the acidic or the basic nature, you always need the indicator. Okay? Because indicator is something like which is indicating those specified properties. Okay? So just seeing on them, you can't say it is acid or a base. Okay? You need to use the indicator. Else you have to taste it. And I'm sure that that is not a good idea actually to taste acid and a base. See, acidic and basic oxide do not react with each other, but their solution will react. Okay? Acidic and basic oxide won't react. You can't say that, sir, CO2, what will happen when CO2 will be treated with the Na2O? You won't get anything. Okay? Please copy and then confirm. Okay, why? Acetic and box basic oxide. Okay. See, whenever for a reaction to be takes place, there is an exchange of the energies. Means for the breaking of the previous bonds and the formation of the new bonds. Okay. So they want generate much energy over there to we can say to be reaction with each other. Okay. They want to generate much energy over there. That's why they won't react with each other. Okay. So we need something else, which actually we can say that is able to break those previous bonds. Okay. Sorry. Got it? Copied? Okay. Let's move on. Amphoteric oxides. Amphoteric are those which react with acid as well as a base. Please copy and then confirm. Please confirm me after copying that. Guys, have you copied that? Etanagar Tamil long. Okay, take copy. No, amphoteric oxides won't react with each other. See, it is possible only when in the amphoteric oxides, one of the oxides having the lesser acidic nature, whereas the second one has the higher acidic nature. So in that case, one of them would react, would behave as a acid, or otherwise, and other one will be as a base. In that case, it is only possible. Otherwise, if both are having the same strength of amphoteric character, they won't react with each other. Okay. See, base and base do not react with each other, na? And acid do not react with each other. I'm just saying that acids and acids do not react with each other just because they have the same character. Similarly, base and base do not react with each other just because they are having the same character. You are saying amphoteric oxides. If both are having the same strength, then the amphoteric oxides won't react with each other. Okay? I'm just saying, in the amphoteric oxides, if it is possible that one can behave as more acidic, whereas other one can behave as more basic, or we can say less acidic. In that case, it might possible. Otherwise, it won't possible. Aluminium and acid. It is just being treated with the HCl to get what? AlCl3 and water. Reaction is actually not balanced over there. Reaction is not balanced over there in the equation number 1. So you have to balance that reaction. Any example of what? Tamalong, are you clear? Guys, please make sure when I explains anything to you, it got clear to you. If it is not, just inform me at that time, sir, it is not clear to you, please repeat it. I'll repeat that again. Okay? No, there is no such example right now. Means I haven't. There is no such known examples to me right now. Okay, I haven't seen such examples. Okay, Tamalong, which is not clear. What doubt is not clear to you? Please tell me. Mark that again. Okay, you were saying the reaction of aluminium with the HCl, na? Dear, it is just displacement reaction, na? And the reaction is not balanced actually. Okay, so to balance that reaction, to balance that reaction, just do this one. 1 second. See, Al2O3 with HCl. We are getting the AlCl3 with water. Balance this. Put 6 here, 2 here, and then 3 here. This is the balanced reaction. Please copy this one. Update that reaction, that unbalanced reaction, to the balanced one. Okay. Now clear? Tamalong. Please copy this balanced reaction. Because I have seen this reaction many a times. Balancing, I guess, has been discussed in the chapter number 1 now. It's okay if you're not clear with the balancing part. Just let me finish this chapter. Okay, just prepare a doubt list. I'll clear all the doubts. Means I'll teach you that how to balance the chemical reaction. Cool? Itanaga? I'll tell you. So, but once get complete this one. Means this chapter. Okay, have you copied that? Next, neutral oxides, non-metals that form the oxides that show neither basic nor acidic properties. Okay, are neutral oxides. Examples are, please do not write water. Please do not write water in the example of neutral oxide because water is not neutral, it is amphoteric. So you have to write examples only carbon monoxide and the nitrogen oxide, which is nitric oxide. Okay, I'm repeating. In the examples of neutral oxides, do not write water. Please write carbon monoxide and nitric oxide. Okay, copy and then confirm. Copied. Yes, these two are poisonous, especially the carbon monoxides. Means not that too poisonous that you simply inhale and you will get, you will pass away. Not something like that. But yes, it is a kind of slow poison. Okay. But yes, excess of inhaling will cause us to the death. No, it is not property of the neutral oxide. It is just the gases are over there. Means they are having the properties. No, neutral is not poisonous every time. It is just like we are studying about these gases and these are poisonous. That's it. Okay. Don't think that all the neutral oxides will be pure poisonous in nature. Like nitric oxide is not much poisonous as you compared with the carbon monoxide. Okay. And even I was telling you that carbon monoxide is not that too poisonous. Okay. Got it, Tamil Long? And Itanagar? Okay, so guys, there is a reactivity of metals with water. The question is for you. You have to write the answer that do all the metals have same reactivity with the water? Potassium, iron and gold. Do they have the same reactivity? Think carefully. Okay, what about you, Tamil? Oh, sorry. Yes, Tamil Long. Okay, very good, Itanagar. What do you think, Tamil Long? Okay. Yes, your answer is correct. Different reactions with water. Metal with the cold water will give you metal hydroxide and hydrogen gas. Hot water, same thing. Steam, you will get the metal oxide and hydrogen gas. Okay. So this is actually the different reactions of metal with the different type of water. Okay. Cold water means a very low temperature of water. Hot water means it is a relatively higher temperature as you compared with the cold water. And steam means the maximum temperature that water can achieve, which is 100 degrees Celsius. Means at 100 degrees Celsius, it will be in the form of steam. Okay. So first of all, please note down this one. And if you would like to ask anything based on this one, if it is not clear to you, you are most welcome. Ask me. If it is not clear to you. I'm just saying that in different conditions, at different temperatures, see the different type of waters written over there, it means that they are saying they have got the different temperatures. Okay. So at the different temperatures, we will get the different oxides, different compounds. Is it valid for the every metal? All the typical metals. All the typical metals, it would be applicable. Okay. But yes, every metal won't react in such manner. Like platinum is unreactive over there. Okay. So if you are leaving the exceptions, then it is true. If you are considering the exceptions, then it won't true. Done? Yes, they all are the same metals. And you are getting such type of compounds. Okay. See? Potassium, sodium, calcium with cold water. Okay. So these are the reactions. You will get the hydroxides and the hydrogen gas. Okay. So this is nothing but that uh, reactions which were written in the form of the words over there. Now they are in the form of the chemical equations. Okay. Nothing else. So please copy these chemical reactions and confirm it. Cold water, actually we are talking about the cold is nothing but the normal water. Means cold and the normal water will have almost same reactivity. Done? Yes, it is exothermic in nature. Heat will be released over there. Have you copied that, guys? This is the reaction. Please copy. Please copy and then confirm. Yes, this one is also no. This one is also exothermic, not endothermic. No, you won't count the energy from the hot water. As in, that is the energetic state of that one, na? We define the process as the endo and exothermic when we supply energy from the outside for that particular process. And if you are getting energy from the given chemical reaction, then it would be the exothermic. And if you are supplying the energy from outer source, then it will be the endothermic. Okay. It is something like that. Hot water is already a substance which is in highly energetic state. Copied. Metals with the steam. See, this is the reaction that is about that we were discussing initially. Okay. So please copy this reaction. H2O in gaseous state means H2O is now present in the form of the steam. Okay. Please copy these reactions. You need to remember these reactions. Quite important. Please copy and then confirm. Sir, are these redox reactions? So yes, these are redox reactions. Oxidation state is being changed over there. Copied. This is, guys, the setup actually, that metal reaction with the steam. Okay. One second. Guys, please copy this one. Need not to draw that setup. Okay. That is the different behavior shown by the elements differently. See, potassium and sodium has a kind of a same behavior, that both burns vigorously to form the oxides. With cold water, they form hydrogen gas and alkaline hydroxide solution. Okay. Then violent reaction to give the hydrogen gas and salt solution. Okay. So these are the behavior of the few important elements over there. So please copy this one. This is important to us. Okay. Please copy and then confirm. Copy and then confirm. And if you would like to ask any question from this one, please, you're most welcome. Copied. Okay, okay, okay. Just copy and then confirm. Tamalong, are you there? It's been a long time that I haven't seen you on the chat screen. It's about 20 minutes. Okay, now I have seen you. Cool. Let's move on. So finally, after completion of that, there is a test time. So please look at the question, read the question carefully, mark your answer, and then see how you have learned today. Okay? Please start with the question. Oh, wow. Quick answer. Absolutely right. Next one for you. Okay, Itanagar has given the answer. Am I along? Wow. Good. Congratulations to both of you. Next question. Okay, let's see. Time along, I haven't got your answer. Oh, Itanagar has changed the answer. Tamalong has given the answer. Okay. Very good, Itanagar. Tamalong, you just missed something or missed something. Okay. Do you have any doubt? Tamalong, are you clear after what? After the answer means after looking at the answer. Are you clear with that? Do you have any doubt? Would you like to ask anything? Cool. Also, this is the summary, guys. Summary means whatever we have learned today. Okay. So, I don't think so that we need to copy that. Okay. I'm going to start the next one. This is we have discussed now. 1 second. Give me a minute, guys. Okay. So guys, there is a recall test based on the concept that we have discussed. So please mark your answers quickly, okay, so that we will proceed with the new concepts. Once you have attempted all three questions, okay, cool. Tamelong, have you done? Have you done these questions? Do these two questions as well. Done? Okay. So let's check out the answer. Very good, Itanagar. Tamelong, how many correct you have got? Please tell me. How many correct answers you have got? Congratulations to all of you. Well done. Okay, so let's move on. So guys, the next topic is reaction of the metals with the acids. Okay. See, whenever acid is being treated with metal, they form the salt and the hydrogen. This is a general reaction. That's what we have to learn over here. That whenever, and this is the thing that you have to remember, that if you learn the general reaction, then you are able to answer the questions wherever you are getting the metal. Okay. So just remember that whenever a metal is being treated with the dilute acids, it will provide you the hydrogen gas along with the salt. Okay. And simply I'll tell you one thing, that from the acid just remove the hydrogen. See, I'm telling you that how to write the answers. Look at this. One second. See. Let's say suppose this is the metal, Mg, and this is your LCl, which is an acid. You have to write the salt and the hydrogen. So first of all, write the hydrogen. Obviously, to remove or to get the two hydrogen, you need two hydrogens on the left hand side as well to write the balanced equation. Okay. Now what you have to do? Combine this magnesium with the Cl, and this one will be what? MgCl2. That's it. Similarly, for example, you have got the Zn, and you are treating it with the HCl. Do one thing, remove the H2. If you have removed the H2, so obviously on the left hand side you should also have the 2 hydrogen atoms. Simply put the 2 over here. Okay, and obviously it means that 2 hydrogen and 2 chlorine. So just combine chlorine with the zinc and you'll get what? Z and Cl2. This is how you can write the answers for all the metals when they are being treated with the dilute acids. Okay, so this is a method to write the answers. Have you got that, guys? If it's not clear to you, please let me know. I'll clear it again, means I'll discuss it again. Clear? Tamilong, Itanagar, guys, are you clear with this one? You are saying then what about the aluminium? Dear, aluminium actually forms the AlCl3, na? There's a little bit different thing. Okay, that forms the AlCl3. Okay. First of all, copy this one. Please copy this one. Copy and then confirm once. Copy and then confirm, guys. Yes, in the current situation, they are being basic in nature, and most of the time. Okay. There are some common examples. Okay. Again, dear, the taste will get changed when you prepared solution of that, na? If you are able to prepare the solution of the metal, then it will taste better. So metal, there is the, in the previous questions, or we can say the question which is in front of us, is actually metals are not present in the form of the solutions, na? They are simply substances. So how they can taste better? They won't taste better. Okay. I hope so it is clear to you, Itanagar. If it is not, please, you can just tell me again. And guys, these are the some common examples, so please, you need to remember these examples, quite important for the examinations. Remember. Okay. Itanagar, I was just saying that to, if you want to taste that, not you want to taste that, you are saying, do they taste better? No, they don't, they won't, na? The development of the taste will be when you have prepared the solution of that. Is that magnesium solution over there? No. Is there zinc solution over there? No. Is there aluminum solution over there? No. Actually, the point is, when you have prepared a solution of that, means if you dissolve metal into water and you will get something, that is the solution. If you taste that solution, that will be better in nature. That's what I'm saying. Okay? It's like the iron. Okay? It's like iron. If you taste the iron, it won't taste anything, no? It won't give you any taste. No, neither bitter nor sour. Okay? But obviously, if you prepare the iron solution, it will have a certain taste. Okay? So to development of the taste, first of all, you need to dissolve it into the water to prepare a solution. That solution can give you something, some taste. Now clear? If I was too fast, please just tell me. I'll be little bit slow down. Clear now? Itanagar? Cool. Please copy and then confirm. Oh, you have copied that. Oh, when metal reacts with dilute nitric acid, hydrogen gas is not evolved. Why? Yes, mark it. Metal on treatment with the nitric oxides do not give hydrogen. Please mark this, then we'll check out the solution section. Yeah, definitely, dear. Look at this. Copy and then confirm. Iron 2 is actually the oxidation state of that. 2 is representing the charge on that. If you are not understanding the meaning of the oxidation state, 2 means the charge, the plus 2. Okay? Then check out this one. Nitric acid is a strong oxidizing agent. So as soon as H2 is produced in the reaction between metal and the dilute nitric acid oxidizes this H2 to the water and get itself reduced to any one of the nitrogen oxides. Okay, exceptions are this one. Means actually what happened, the question was why H2 is not being formed over there. Yes, H2 is definitely being formed over there when you treat a metal with the HNO3. But actually what happened, that HNO3 is a very strong acid. Okay, so what it do? It convert that hydrogen into the water. Okay, so we can't see the hydrogen over there, but yes, we can see the H2 over there. Okay, so this is the point that why we can't get the hydrogen over there, because the hydrogen is get converted into the H2O. Okay, that's what does it mean. So I hope it is clear to you. Please copy this one. If If still it is not clear to you, just let me know. Please copy and then confirm. Guys, if I'm fast in explaining the queries, please just tell me that it is not clear to you, or I'm too fast over there. Okay. Actually, I'm on my normal pace. Okay. So might be you're comfortable or not comfortable. If you're not comfortable, just let me know. Okay. Yes. Means in the reaction of the magnesium and the manganese, it is not oxidizing H2 to the H2O. Okay. But in other cases, it will. It is being treated with the sorry, the oxygen is being treated, the nascent oxygen is being treated with the H2 na, to convert it into the water. See, it is like HNO3 is converting H2 into H2O, and itself, after breaking, converted into NO2, NO or N2O. That's what does that statement mean. Okay? See, actually, it is trying to say this one. No? I'll clear it to you. Sorry. That HNO3 converts H2 to H2O and itself get converted into NO2, NO or N2O. Okay? Got it now? Is it clear to you now? Always. You're saying then where does its own hydrogen goes? It actually being dissociated, so it either goes with the H2O, okay, ultimately that H2 which is being prepared, or we can say we are getting over there, was because of that HNO3, na? That H2 was because of that HNO3. Okay, so that is itself is giving the first H2, and then that H2 is being converted into what? H2O. See, there is not exactly one molecule of the HNO3, na? There are many molecules of the HNO3. Getting? Wait. Okay. Are you clear, Itanagar? Itanagar, are you clear with the doubt? If you're having any other doubt, please ask me. Means, still if you're having a doubt in this one, just ask me again. If you're not exactly clear with your thoughts. Okay, getting. See what I was saying, na? See what I was saying. See, actually the HNO3, see, this HNO3, these two hydrogen are converting into the H2. Okay. So, actually what's happening, that this HNO3 provides you nascent oxygen as well, means this oxygen. Means this HNO3 is being dissociated over there, giving H2. Okay. Now that H2 get combined with this oxygen to give you what? H2O. And whatever remaining is there, whatever, will be either NO2, depending on the situation, what type of situation we could have, N2O or NO. Okay. It is like HNO3 gives you H2, that H2 will convert into the water. Okay. And whatever left after that will be either NO2, N2 or NO. Okay. Like in HNO3, if you remove H2, okay, you're left with what? NO2. Okay. See, if you combine these two, na, you will get this one. Look at this very carefully. This is nothing but the breaking of the HNO3. Getting? Obviously, that is not balanced one. That is not the balanced reaction. You can balance that. Okay, if you want to. Okay, that's cool. Okay, so guys, let's wind up today's session. Okay, we will continue after that. Okay, so you have to revise it again at your home. Okay, and we will continue after that. Okay, so guys, thank you so much. I'll see you next time. Till then, take care. Bye bye. Have a good time. Please take care of yourself. See you next time. Yes, good night.